differentiation. The diagram shows the curve y equals sin x cos 2x and its maximum point M. Find the x coordinate of M 3SF. So maximum point means the point at which the tangent line is a horizontal line, and horizontal line means the gradient is 0 and gradient is dy dx or y prime. So maximum point means y prime equals 0. So what is y prime? Well, since the y is a multiplication, we have to use the product rule. This is the product rule from MF19. So the du dx is what we call u prime, the dv dx is v prime. So if we're differentiating u times v, the result is u prime v plus v prime u prime v plus v prime u. So if the u is sine x, the u prime is the derivative of sine, that is cos. So the u prime is cos, the v is exactly the same. Now v prime, if the v is cos, cos becomes minus sine, so we get minus sine. The angle is 2x, but we multiply by 2 because of the derivative of the angle. So the derivative of 2x is 2. This is because of the chain rule, so we have to multiply by 2 because of these 2. Okay, that's the v prime. The u is exactly the same, so we have the y prime. Now to solve y prime equals 0, we're gonna have to use the double angle rule, because we have 2x and x in the same equation. We cannot really solve this. So we use the double angle rule for sine. We replace the sine 2x with 2 sin x cos x. And we also replace the cos 2x with one of these here. So since this is all in sin x, so you can use any of the forms actually here. Okay, but here we are using 1 minus 2 sine squared x, because when you factor out the cos later, you will get something with sine squared, something with sine squared. So you can just use 1 minus sine squared to simplify things. But actually, if you use cos squared minus sine squared, it'll work as well. You're gonna use tangent squared in the end, so it doesn't matter. Okay, so here I'm using 1 minus 2 sine squared. And now we factor out cos x. So cos x, we factor out. From the first term, we still have 1 minus 2 sine squared x. And from the second term, we still have minus 2 times 2 is minus 4. Sine times sine is sine squared, so minus 4 sine squared. So we factor out cos x. And now we are solving. This is equals 0. So cos x equals 0, which means using inverse tangent, the x is inverse cos 0, which is pi over 2. This is rejected because in the graph, obviously the x is not pi over 2. If you look at the graph here, this is pi over 2, and obviously this value is far from pi over 2, so that's rejected. And now for the 1 minus 6 sine squared x, so from here equals 0, we subtract 1 from both sides, divide both sides by minus 6, take the square root of both sides, we have plus minus. So we are using the positive because we need it in the first quadrant. So inverse sine positive 1 over root 6, we get the x coordinate of the stationary point. Alright, see you again next time.